We are the very android life in the known universe. I mean, imagine that we're the key place where there is information in this tremendous framework. Cosmologists, by and large, around the world, are in wonderment of this, continually prompting transparency. The James Webb Space Telescope has gotten the subtle focus of city lights, an endless 7 trillion miles from Earth, beating all questions. This staggering achievement accomplishes more than just growing our perspectives to the extent of what we are familiar with the universe. The theory goes wild as specialists pore over the data, searching for signs that could open the mysteries of these stunning, exceptional aids. The contemplations are astounding. Check that we are continuing in the means of a few remarkable individuals in the universe, that the universe is amassing with life and progression, extremely far outside our capacity to make heads or tails of. Is it possible that these faraway lights show the presence of extraterrestrial social orders? What's the significance of this for our understanding of the possibility of life in the universe beyond Earth? Join us as we check out how the James Webb Telescope just saw city lights 7 trillion miles away. Shipped off into space on Christmas Day 2021, the James Webb Space Telescope was expected to beat the particularly respected Hubble telescope in getting extraordinarily sharp photos of newly discovered brilliant objects, planetary systems, and more. An undeniable objective of the JWST is to focus on the development of the earliest universes by evaluating the faraway abutting inhabitants of the universe. This is helpful since the journey time of light throughout our universe is billions of years. When the JWST amasses light, it gets these objects precisely as they were billions of years ago. Space specialists measure distances in light years, which is the distance light can go in a year. To show this reality, the mission's first major sensible endeavor was a tremendous field picture that was presented on July 11, 2022, by U.S. President Joseph Biden, while he was talking from the White House. While the Hubble Space Telescope fixated on a specific locale of the sky for 10 straight days, beginning on December 18, 1995, the Hubble Deep Field got an impression of a district that was only a little spot, making up around 1/1,000,000th of the entire sky. By a wide margin, the majority of the 3,000 currently unknown things found by Hubble were enormous frameworks tracked down billions of light-years away. With its focus on the SMX 0723 universe cluster, the JWST Deep Field covers a correspondingly small sky area. The universe structure SMX 0723 is 4.6 billion light-years away, and the more distant universes behind it are increased by the remarkable gravitational field. The twisting of the brilliant systems is bent into giant turns, where the gravitational field is most intense. In one case, it was confirmed that it took a distant framework's light 13.14 billion years to arrive at the telescope, coming as a result of its journey through space. The light being communicated extends as the universe grows. The primary objective of the JWST has been to get noticeable light from their stars into the infrared. Space experts can obviously see JWST visible light photos of abutting vast frameworks taken by Hubble and other telescopes. By gathering data at those frequencies, we can perceive how inestimable frameworks have advanced throughout gigantic timescales and joined into the shapes we notice today. More astounding than the sheer number of structures in the JWST's first deep field picture is how rapidly it was caught, in not more than hours, compared to days or even weeks for other telescopes. Wherever it looks, it can't avoid the motivation to find new universes. Infinite framework clusters aren't the only items going about as enhancing focuses. Specialists used the JWST to catch an image of a couple of universes designated VV1191, so they could study how the light from one of the pair changed as it went through the other. The impacts of this study will uncover the properties of the interceding infinite frameworks. Advancement, besides, gives the idea that the JWST may have made an incredible discovery: light from a very distant world. The clarification of the possible presence of auroras on an exoplanet came from the official JWST site. The shortage of a host star and the cold temperature make it hard to pinpoint where the energy in the upper air is coming from. Anyway, the fact that the thing showing aurora is indeed discharging methane is critical. Just like auroras on Earth are caused when bursting particles from the sun are caught by our planet's magnetic field, charged particles then clear their way through Earth's atmosphere near the poles, where they crash into gas particles, making a splendid light show called the aurora borealis. Jupiter and Saturn have similar auroral peculiarities due to the solar wind. However, the puzzling W1935 has no star to circle, so its auroras are an immense secret. Everybody's uncertainty stayed on track using Proxima Centauri and TRAPPIST-1, around 4.4 light-years from Earth, inside the Milky Way. Specialists have identified the presence of water on the exoplanet, and furthermore, the possibility of life on the world can't be rejected. Are we finally going to see evidence of life beyond Earth? Just last month, the JWST saw another exceptionally tremendous black hole. This giant black hole was found in numerous frequencies and is consuming everything around it. This discovery is 40 million times as huge as the Sun. However, what does this mean for us? The JWST has seen that this very enormous black hole has been present since the beginning of the universe. Probably isn't moving. This monster is quickly consuming everything in its close-by region. The discovery was made by Dr. Lucas Fu and Professor Alastair Z of the Beigwan School of the NA in Israel. As per their findings, the very enormous black hole is right around 3 times heavier than the Sun, making it a massive object. Luckily, it is considered an immense distance from Earth, around 129 billion light-years away. Still, it is moving closer, with the black hole consuming everything around it at a quick rate, as shown by the red shift. When the JWST started sending back its limited data, scientists were energized as they scanned through the information that came in for the uncovered program. 3 little objects with a weak red glow grabbed their attention. They immediately thought it was a nearby gigantic black hole. Anyway, when they examined the data using gravitational lensing, they found something significantly more interesting. The discovery of similar peculiarities in other early universe exceptionally huge black holes has given new insights into the development of both the black hole and its host universe, as well as the connection between the two. This is still largely puzzling, but it may be the verification of the early-stage development of massive objects like star-forming materials that fell into black holes. Space specialists can't yet see exactly what's happening in the pictures sent back to Earth, but one thing is clear. The James Webb Space Telescope is continually finding new peculiar objects. We have the pleasure of exploring space and being charmed by the stunning lights of planets and stars that float across the universe, light years away. Not only does the JWST allow us to see far beyond what our eyes can grasp, but it has also uncovered a mysterious object in one picture. This picture, which focused on something else, was taken by the European Space Association, observing 2 young stars forming around 1.47 light-years from Earth. Anyway, there is a little orange mark at the bottom of the picture that appears to resemble a question mark. Obviously, this little picture is far from trivial. In fact, it's enormous. The question mark shape was captured while observing the arrangements of young stars known as Herbig-Haro objects, which are surrounded by massive rings of gas and dust. Concerning the question mark shape itself, it could be the case that, because of the 2-dimensional picture presented by Webb, it seems this way according to its specific viewpoint. As of now, we don't know what it is, and without further review, we may never know. However, the discovery has been confirmed by experts, and it is possible a far-off structure or maybe universes that are collaborating with one another. The odd question mark shape could be a result of their combined efforts. Given the flood of far-off twisted structures uncovered by Webb, there is an ongoing surge of new eccentric questions. Everybody's eyes are focusing on a particular arrangement of Earth-sized planets that could hold the key to finding extraterrestrial life. The determined issue, which includes the need for confirmation of advanced extraterrestrial life in the universe, isn't getting through the high probability that such creatures exist, but it could finally be settled. Where are these planets? They sit precisely 40 light-years from Earth. Also, the nearby star system is known as TRAPPIST-1, which has 7 planets orbiting it. In their mission to track down livable planets, NASA is considering a wide array of models, beyond just planet size and distance from its star. A more sensible approach is to assess the general conditions of the planet's atmosphere, as this would allow analysts to determine if the planet is suitable. The Infrared Spitzer Space Telescope, which is part of NASA's space investigation mission, uncovered the 7 habitable exoplanets circling the same star, TRAPPIST-1, quite a few years ago. The James Webb Space Telescope has now measured the temperature of TRAPPIST-1b, one of those planets. JWST has consistently made critical discoveries since its launch, and this finding is the very latest in a series of record-breaking firsts. This is the first discovery of light emitted by an exoplanet as small and cool as those in our own nearby planetary system. No other telescopes have been able to measure such weak mid-red emissions, but JWST can. It took only a couple of hours for the JWST to make significant discoveries after beginning to work with its cameras and instruments, confirming its essential goal of finding the oldest known galaxies. Although this goal remains a major objective, the vast and remarkable complexity of discovering new and important facts has many scientists more excited than ever. The James Webb Space Telescope continues to captivate the imagination of scientists and the public alike. As it reaches unprecedented distances and uncovers remarkable objects in deep space, its discoveries are reshaping our understanding of the cosmos. This journey into the unknown is not just a testament to human ingenuity, but also a stepping stone toward unlocking some of the most profound mysteries of the universe. Among the most exciting aspects of the JWST's discoveries is its ability to observe distant galaxies, stars, and planetary systems in greater detail than ever before. With its infrared capabilities, it can peer through cosmic dust and gas, revealing hidden features of celestial bodies that were previously beyond our reach. The telescope's ability to observe objects that are billions of years old has already provided new insights into the formation and evolution of the universe. One of the most intriguing questions that the JWST is helping to address is the search for extraterrestrial life. By studying the atmospheres of exoplanets, the telescope is providing clues about the conditions necessary for life to thrive. Scientists are particularly focused on the TRAPPIST-1 system, where multiple Earth-sized planets exist in the habitable zone of their star. The possibility that these planets might harbor life, or at least the potential for it, has captured the attention of researchers and the public alike. In addition to its work on exoplanets, the JWST is also investigating the nature of dark matter and dark energy, two of the most elusive and enigmatic phenomena in physics. By studying how light bends as it passes through the gravitational fields of galaxy clusters, scientists hope to uncover more about the nature of these mysterious forces that make up most of the universe's mass and energy. The telescope's ability to observe distant black holes is another groundbreaking aspect of its mission. In addition to identifying black holes that existed shortly after the Big Bang, the JWST is shedding light on the role they play in the formation and evolution of galaxies. This research could ultimately lead to a better understanding of how galaxies, stars, and black holes interact with one another, and how they have shaped the universe as we know it.